Alrighty, Earth Science, let's get into it. My green screen is messing up a little bit, and so you might see some fuzziness, and I'm sorry for that. But I figured it was better than um, not being able to see me at all as we go through this lesson, and so I stuck with it. So we're going to talk about insulation. Now we've already talked about insulation a little bit, but we are going to get more in depth with it today. So let's first cover like what is insulation. Remember, the Earth gets its energy from the sun. It's the major source of energy. In fact, the energy that we get, if you are a meat eater, well, the sun gives energy to the plants through photosynthesis. The plants give energy to, say, cows, as the cows eat grass and plants, and then we can eat the cow, or we can eat the plants directly. And so the energy that we're getting from our food is indirectly coming from the sun. And this sun energy, the energy that is received from the sun, is what we call insolation. Now remember, insolation can be broken up into three parts. Insolation. In being coming towards or coming in. Sol has to do with the sun. And ation is having the action or giving action to kind of what was previously talked about. So this is the action of the sun giving in energy, or the sun giving us energy. So that's insulation, and that's what we're going to be talking about this week. So put all three of those together. And so remember, when we are looking at this, whenever you see the word insulation in a question, a handy dandy like go-to problem solving technique is to just cross out the word insulation, and you could write in the word sunshine. The question will make the same or make the same statement or ask you the same question, but it's a little bit easier to answer when you have the word sunshine in there. Okay, so what we're going to be talking about today, the major points of this, is what affects the amount of insulation we get. What affects the amount of insulation that we get, whether it's in New York State or really anywhere on the Earth. So the first one is the angle of insolation, or the angle that the sun's rays hit the Earth. Now, if the sun is giving off rays at 23.5 degrees or 47 or 70.5 degrees, my question is, which angle would cause the surface to be hotter? It's pretty self-explanatory to say, whoops, that the 70.5 degree angle is going to be the hottest. This one right here is going to get more direct rays of sunshine, and so this one is going to be hotter. When the sun is higher up in the sky is when we have the hottest surface. So this kind of goes into the idea that the angle that is greater, the angle that is more direct, means that the sun is higher up in the sky, and that gives us more direct rays of sunshine. In New York State, when is the angle of insolation the greatest? Each day it's the greatest at noon. And why? It's because the sun is at the highest point in the sky then, which also means that noon is when we have the most direct rays of sunlight, which is, if you're wearing sunscreen, noon is the time to be wearing it the most. Which season? Well, it's June. I wrote June. It should be summer. Why? Well, it's because the summer has the highest noontime sun. In the summer, we have the sun highest in the sky. Latitude versus insolation. So this is the second bit. What latitude has the greatest intensity of insolation? Well, it's the equator. The equator has the highest amount of sunshine. It has the most sunshine on the Earth. The further up you go, or the further down you go, the further away from the equator, the less insolation you get. Why is that? It's because it receives the most constant levels of high insolation. Which latitude has the least amount of intensity? Now it's both the 90 and the 90 north and the 90 south. The north and the south pole. And why is that? Because it receives the least amount of sunlight throughout the year. And so if we think about this, in the winter, the sun is lower in the sky, rising in the east, setting in the west. In the spring and in the fall, we have kind of the interim, the mix between the two. And in the summer, we have the highest noontime sun and the longest days. So how long the sunshine lasts for. New York State, when is the duration of insolation the greatest? Well, we already talked about this. It's the summer. What latitude has the longest duration of insolation and when? Well, the Arctic Circle has the longest duration. And why isn't it warm there? It's because it never really gets high up in the sky. The sun can last very long, or can be in the sky for a very long amount of time, but it doesn't really get that latitude, or sorry, not latitude, that angle upwards. It doesn't really get very high altitude up in the sky, and so it has very low angles of insolation for a very long amount of time, and that doesn't really give it a whole lot of heat to be warm. What latitude has approximately 12 hours of insolation year-round? That's the equator. The equator has pretty much 12 hours of insolation no matter what part of the year you're in, which makes it hot consistently for the entire year. Why is that? It's because it has very high angles of insolation. So let's think about the Earth here. So if we say that the Earth is tilted, remember it's tilted on that 23.5 degrees. And we have the Tropic of Cancer being that 23.5 degrees north, and 23.5 degrees south is our Tropic of Capricorn. This is going to greatly affect our insolation. So insolation reaches the Earth from parallel rays. If the Earth was flat and positioned perpendicular, the intensity of insolation would be the same everywhere, but we know that's not the case. So we have different levels of insolation in different places. And so when we look at the Earth as an oblate spheroid, the places on Earth that we have perpendicular rays are going to be hotter, and the places where the rays are kind of coming in over a larger area or over more locations are going to be colder. And so it has a little picture of that here. The Earth, in this case, isn't tilted, and we'll talk about that a little bit in a second. But notice that when these parallel rays come into the Earth, there are areas where it is covering a smaller location on Earth. And so this, if we were to look at like a flashlight or a heat lamp, that flashlight or heat lamp is going to only cover a small area right here, which means this small area, this pinpoint area, is going to get really hot. But if we have a parallel ray that's coming in, and it's covering a larger area like this, because it's covering more of the curved side, where this is more perpendicular, this is more of the larger area of the curved side of the sphere, this area is going to be colder. Because it's not because it's getting less energy, but it's because that energy is being spaced out over a larger area. You're giving the same amount of energy to a larger area, which means it's not going to get as hot. Okay? So let's talk about the atmosphere. Well, the atmosphere does protect us from some of this insolation, which we should be very happy about, very grateful for, because we don't want all the insolation that the sun is going to give off. Some of it is absorbed, taken into the Earth. What color and texture do you think best absorbs? This is a review. We should already know this. Rough, dark materials. That's why like a tarred driveway is hotter than, like, say, a smooth, lighter sidewalk. And some of it is reflected. It bounces off, whether the material is the ozone layer or just a mirror. What color and texture is the best reflector? Well, it's the opposite. It's the smooth white materials. That's a review from earlier. Some refracted materials can be just light that is bent, or insulation that is bent as it passes through. So you put a pencil in a glass of water and all of a sudden it looks like this. Notice that the pencil isn't actually bent in the water, but the water bends some of the light, which makes it seem like it's not connected. And that's just because the water is bending the light a little bit. And we have our little spectrum right here, which our prism, which shows scattered light, where we have white light coming in, and it's scattering. You'll see that scatter right here, and separate out all the different colors there. And so that scattered light can also be really, really great for us for some of the higher energy light that the sun gives off, and kind of when the ozone scatters it, we don't get those direct intense amounts of energy. Okay, so that's the basics of insulation. I kind of went through it really quick. Um, a lot of it is kind of intuitive. Um, but yeah, so we're going to touch base on some lunar stuff next week, and I will see you there. Bye, guys.